Welcome, class. Today our session title is Week 13, Session 49, Quantitative Chemistry Challenge Set. We will move slowly and make the chemistry understandable. Your goal is to solve mixed mole, solution, stoichiometry, and acid-base problems. Listen for these key terms: mixed practice, unit path, molarity, stoichiometry, neutralization. First, keep the three chemistry levels together. Mixed chemistry problems are decision problems before they are calculation problems. Your first job is to identify the type of quantity you have and the type you need. Then choose the path: molar mass, Avogadro's number, molarity, dilution, mole ratio, or percent yield. When you feel stuck, ask, what did I observe? What are the particles doing? And what symbol or calculation represents it? The core model is this: write a unit path before calculating. If the units cancel correctly, the chemistry is usually on track. Do not rush to an answer. Build the model first, then let the model guide the calculation or explanation. Now let's work an example. Choosing the right path. Question: how many grams of sodium chloride are needed to make 250 milliliters of 0.500 m solution? This is not a stoichiometry reaction because no balanced equation is given. Use molarity first. Mole equals m times L equals 0.500 times 0.250 equals 0.125 mole sodium chloride. Then use molar mass. 0.125 mole times 58.44 grams per mole equals 7.31 grams sodium chloride. Notice how the answer comes from evidence and reasoning, not from guessing. Here is a second example. Question: how many grams of CO2 form from burning 10.0 grams of CH4? This is stoichiometry because a reaction is involved. Balance: CH4 plus 2O2 gives CO2 plus 2H2O. Then use gram CH4 gives mole CH4 gives mole CO2 gives gram CO2. Now answer this self-check. Which formula connects molarity, moles, and liters? A strong answer should include M equals mole per liter. Hint: molarity is moles of solute per liter of solution. Before you leave, practice actively. Task 1. Find grams NaOH needed for 100 milliliters of 0.250 m solution. Task 2. Find grams CO2 from 8.00 g CH4 with excess oxygen. Task 3. Find percent yield if 5.20 g is collected and 6.40 g is theoretical. At the end of your study, write one sentence beginning, "The chemistry idea I must remember is." For more practice and exam preparation, visit www.bridgetoexam.com.